Have you ever wondered what happens about 30 feet below your feet, or maybe perhaps how volcanoes are formed, or really how geysers work? Well, I am going to clear that up for you in a few easy steps, really. So, I got most of my information from the wonderful, magnificent book called Geology for Dummies. So, my first point is the rock cycle. The rock cycle works like this. It goes from magma to igneous rocks, from igneous rocks, ground up by weathering, into sedimentary rocks, or sediment, which then gets condensed, usually in river beds, via not really heat, just pressure, into sedimentary rocks, which is normally what you find fossils in. God, I love fossils. So, sedimentary rocks then get pressurized even more over layers upon layers upon layers of more sediment, that makes more sedimentary rock later, and pressurized with heat and more weight, which makes metamorphic rocks. Metamorphic rocks and sedimentary rocks can then be weathered into more sediment, yada yada yada. The metamorphic rocks are then pressurized even more until they get melted. Well, melted, but it basically gets turned into a liquid goo called magma, which then once again gets turned into igneous rocks, which is why it is a rock cycle. With the rock cycle in mind, we move on to plate tectonics, which is another basic concept of geology. The plates, mainly the lithosphere of the entire thing, the lithosphere is partially molten rock, which is mainly where the igneous rocks come from. Then there's the continental crust, all the way on top. Basically, imagine the entire Earth crust, just in that view right there, as a cake that's been cut by a katana and then shoved together, like this. When the oceanic crust, which is denser than the continental crust, crashes into the continental crust, the oceanic crust, due to the fact that it's heavier, and the continental crust, due to the fact that it's lighter, is pushed up, while the continental crust, or the oceanic crust, goes down. That process makes volcanoes form because it is forcing up any loose magma up, which turns it into a pocket of molten rock. That pocket of molten rock is then forced up in a mountain. Mountains are basically crumples in the earth. When the plates collide, it basically also pushes up towards the top, making a mountain. So, then we go to geysers, which, on the topic of geysers, which always form on the slopes of volcanoes and also within the caldera, or crater, of the volcano. The geyser in that picture is in Spanish, because I couldn't find an English one. But I didn't need the words on the diagram. I just needed the geyser, because that was the best picture I could find. But anyway, beneath that entire picture, you'll notice that the dirt is depicted as glowing slightly orange. That is because that the earth below it is being heated. Those pockets on either side of the main channel is where all the water is stored. The molten rock below the geyser, or the batholith, which is the massive pocket of magma, heats up every single one of those pockets to their boiling point, which, when you boil it up, it needs a place to go, because gas needs to escape. The gas will then go out of the channel and force into the main channel, due to the sheer amount of pressure and the fact that you have all these pockets of water trying to force their way up through one narrow tube. causes a massive explosion of water straight up into the air. This is what causes a geyser. Then the water, after it crashes back down onto the earth, is replenished within those pockets via water runoff, which is how they keep going and going and going and going. So, that is basically Geology 101 for dummies in its most basic form. I could go on for this for hours and hours and hours, and I could. This is a topic that interests me, though rocks really don't move very much. I just like them. But I hope that I have kindled your interest, even just a little bit, because rocks can be very interesting. You can find all sorts of history in them. We just covered the rock cycle, plate tectonics, and how it forms volcanoes, and how geysers interrelate to all of that. And just because people showed an interest in this particular rock and what it looked like, my last presentation, this is lapis lazuli. It's a lovely rock.
That name.
It is a weird name, isn't it? It's foreign. I think it's African. Anyway, and that concludes my presentation for today.